Okay, hello guys, this is your SI coach, Lamelli, and I'm going to be going over this problem right here. I've had a lot of questions on this. They're all good questions, and I think there might be a bit of confusion or just some things that I think all of you need a little bit of clearing up. I'm not going to do all of these, for obvious reasons, but I'll go ahead and do sodium for y'all and aluminum, because I don't know, I just want to do those two. But yeah, so I'll go ahead and write in this atomic number, because it's 8, you can see it right here. Boom. Now let's get started with sodium. So the atomic number for sodium is going to be 11, and from what you guys can remember from that means there's going to be 11 electrons in there, but that's not what we're after. We're after valence electrons. If you look at the table I gave you guys before, you know that this right here, I'll just draw a quick line, would be the S, or the S orbital. It would be the 3s orbital. So sodium is going to take up 3s orbital and take up the first slot. There's not going to be any p orbitals, so the number of valence electrons is just going to be 1. But sodium does have a charge of +1, so it is going to lose an electron. So we'll just write here 1 lost. This one right here, I assume she's talking about, it just says number of E left after loss or gain. I would think she's talking about valence electrons, because the atomic number for, oh god, I don't know what the heck just happened. Oh, the atomic number for oxygen is 8, which means it has 8 electrons in the element, and it has 6 valence electrons plus 2, would leave 8 valence electrons total. Because if you were talking about total amount of electrons there, then there would be 10 electrons in that oxygen atom. So if we take a closer look at this and see that sodium now has 10 electrons, we could write it like this for Na. It'll occupy the 1s, the 2s, and also the entire 2p, because it will just go from there and occupy the same spot that neon does. So it'll be 2p6, and we can see that if we add these two together, we get 8. So I had a question, I think Amani might have asked that, oh, wouldn't they all be 8? And I'm not sure if all of these are 8, but because of the octet rule, I assume that they all are, and you have to show that with maybe some steps like what I just wrote down there, and hopefully that clears up, a bit of the confusion, because it doesn't say number of valence, it says number of E, so maybe some of you are writing 10, or some of you are writing none, because you thought the valence electrons went away. But they don't, because sodium technically lost that orbital. It will not be, it just won't have a 3s anymore, so it will pretty much look the same as neon, and will have that complete octet, and it will be okay. So sorry about that. We'll just have a +1 for the charge here, and if we write the shorthand, we'll see that the one above sodium is just going to be neon, but it has the exact same thing as neon, so the abbreviated ion electronic configuration for sodium would just be neon, and you would write it just like that. I remember doing these when I was in chemistry 4, and I looked back at my notes and I watched a few videos just to double check this, so This is correct. I will talk to the professor about this if you guys want. You guys can go ahead and talk to her about it, but I just wanted to make sure I was giving you guys the correct thing there. So hopefully that all makes sense. Of course, you can ask me more questions when I post this in the Discord. If it's not going to fit in the Discord, because I can only do like 100 megabytes, I'll just put it on my YouTube channel that hopefully you guys can see pretty easily. I'll be posting videos there because can't really have sessions. Sorry about the dog. Okay, let's just move right along to aluminum. So if we go to aluminum on the periodic table, it has an atomic number of 13. So we know that there are 13 electrons in aluminum. And so why don't we just write out the basic electron configuration for aluminum, non-ion. So we'll have 1s2, 2s2, that's 4, 2p6 is 10, so we're going to need the 3p2, and then we'll just, oh, not 3p, 3s, and then, oh man, I'm messing up all over the place, there we go, we'll need the 3p1. Now, for this, aluminum, if you guys don't remember, as I wrote down right here, there's like a little step that you guys, that's a horrible arrow, so atrocious. There's a little step you guys have to remember. So aluminum will have a +3, zinc will have a +2, and silver will have a +1. If you guys got that memorized, good, because it comes in handy to have that stuff memorized when you're taking exams and stuff, even though you because actually you can't go on the internet for help anymore. I believe your next exam is going to be proctored, so you guys will have to unfortunately be recorded when you take the exam. I'll try to see if there's any leeway with that, because I don't know if all of you have webcams. So that is going to be something hopefully you guys can, you know, talk to me about and see who can do it, who thinks it's just crap, and we'll go ahead and go from there. So let's get to aluminum. So aluminum has 1 valence electron straight up, because it will have 3, because it occupies a 3s2 and a 3p1, so this will be 3 valence electrons, and it is going to lose 3 because the charge on aluminum is +3, so I'll just write 3 lost. And if we go back and take those out, they add up to 3 there. We can just go ahead and scrape all that. We'll see that it goes to 8 valence electrons and follows the octet rule perfectly. If I could just write this down, I don't know what's going on. Oh, I'm on erase mode. Damn it. Okay. Yeah, and the charge in the ion, as I stated before, is +3. And, well, what do you know? This looks super familiar, right? It's the same thing as aluminum. So, again, the abbreviated ion electron configuration for aluminum is also going to be just Ne. That's really cool. Everything's kind of starting to come together. So that is going to be it. If you guys have any questions, feel free to ask. I'm trying my best to get to you guys as much as possible. I am taking a pretty rigorous physics 1D class, and I'm also taking chemistry 1A, and he is just pouring on assignments left and right. So please bear with me. I'm not ignoring any of you. I am trying my best to help all of you. You guys really matter to me, and you know, it's my job to care, and I do care. So this is all very new to me, doing all this online stuff. I never made videos and posted it. I probably sound ridiculous. Hopefully I'm helping. Yeah, so we're gonna get through this together. Hopefully you guys are learning. Hopefully professor is being good and not giving you guys stuff that's too hard. I know the first exam was hard for a lot of you, but hopefully you guys did better on the second one, or on the retake and the curve. So yeah, let's get through the semester. I'll see you guys next time.